In this video, we're going to be solving exponential and logarithmic functions. In example 1, we have log t minus 4 is equal to -1. And remember, if there is no log base listed and log is written out, we're in log base 10. So the first thing I'm going to do is go from logarithmic to exponential functions. So I'm going to say that this is 10, which represents b, to the -1, which is y, is equal to x, which is t minus 4. And now remember, 10 to the -1 is the same as 1 over 10 is equal to t minus 4. And now add 4 to both sides. And 4 could be written as 40 over 10. So t is equal to 41 over 10. Now, every time you're using logarithms, you have to double check to make sure that you're not taking the logarithm of a 0 or a negative number. So here, 41 over 10 minus 4 is 1 over 10. So it would be positive. So that is the solution. If the solution that you come up with makes your log negative or 0, it's just an extraneous solution and we cross it out. In this case, if there was no other solution, there would just be no solution. In example 2, we have log x plus 1 minus log x minus 1 is equal to 1. So the first thing I'm going to do is use the property of logs and combine our two logs into 1. So I'm going to write this as log x plus 1 over x minus 1. Remember, if you have a minus sign in between two logs, it becomes a division with one log, and this is equal to 1. And now I'm going to write it in exponential form. Again, we're log base 10, so 10 to the first power is equal to x plus 1 over x minus 1. And now I'm going to cross multiply, so 10 could be written as 10 over 1, so I have x plus 1 is equal to 10x minus 10. And now I'm going to subtract an x from both sides and add 10 to both sides. And now I'm going to divide by 9, and x is equal to 11 ninths. And now 11 ninths plus 1 is positive, and 11 ninths minus 1 is positive. So this is a good solution. In example 3, we have ln of 2x plus 3 is equal to 0. And we know for a logarithm, for it to equal 0, the inside just has to equal 1. So we could just pull out the 2x plus 3, set it equal to 1, and solve. So 2x is equal to -2, and x is equal to -1. So x is equal to -1 is the solution. And now let's double check. 2 times -1 is -2, plus 3 is 1, and the ln of 1 is equal to 0. In the next example, we have the ln of x all cubed and ln of x raised to the 4th. And you'll notice the difference that the exponent on the left side is attached to the whole ln of x, and the exponent on the right side is only attached to the x. So they're different. So the first thing I'm going to do is subtract ln of x to the 4th to the left side. So I have ln of x cubed minus ln of x to the 4th. And this is equal to 0 now. We subtracted it out. And now I'm going to use the property of logs and bring the 4 out front. So I'm going to write this as ln of x cubed minus 4 ln of x is equal to 0. And now I'm going to factor in ln of x out. So I have ln of x times ln of x squared minus 4 is equal to 0. And now we have a perfect square inside. I can rewrite that as ln of x plus 2 and ln of x minus 2 is equal to 0. And now we're going to set each of the factors equal to 0 and solve them. So we have ln of x is equal to 0. And the inverse of ln is e, so we're going to multiply both sides by e. So we can say that x is equal to e to the 0, which is equal to 1. Anything to the 0 is equal to 1. We have ln of x plus 2 is equal to 0, so ln of x is equal to -2. And then we exponentiate both sides, and we get x is equal to e to the -2. And then we have ln of x minus 2 is equal to 0. And add 2 to both sides. and exponentiate both sides, and x is equal to e squared. So our solutions are going to be 1, e to the negative 2, and e squared. And all of the answers are positive, so they work in both of our ln's. In the last example, we have e to the x plus e to the negative x divided by 2 is equal to 1. And the first thing I'm going to do is multiply both sides by 2, so I get e to the x plus e to the negative x is equal to 2. And now I'm going to multiply this whole thing by e to the x, and that gives me e to the 2x plus e to the 0, which is 1, and that's equal to 2e to the x. And the reason this helped us is because now we can write it in quadratic form so we can solve it. So now I'm going to subtract 2e to the x from both sides, and I get e to the 2x minus 2e to the x plus 1 is equal to 0. And now I can write this as e to the x minus 1 squared is equal to 0. And for those people that don't see it on that step, let's write it over here as well. As I'm going to say that u is equal to e to the x, and then I can write this as u squared minus 2u plus 1 is equal to 0. And now it's a little easier to see the quadratic, and now we can say that u minus 1 squared is equal to 0. So now u is equal to 1, so then we would have 1 is equal to e to the x when we do our resubstitution. And then from here we just have to set e to the x minus 1 equal to 0, add 1 to both sides. So we ended up with the same answer depending on which route you took. The substitution might be an extra step or two, but it allows the factoring to be done a little bit easier. So now we're going to take the ln of both sides, so x is equal to the ln of 1, which is equal to 0. So our solution is 0. E to the 0 is 1, plus e to the 0, which is 1. So 1 plus 1 on the top is 2. 2 divided by 2 is equal to 1. So we were able to verify it. And that's all for this video on solving exponential and logarithmic equations.